Okay, now recording has started. So, dear students, welcome to yet another online session on principles of communication system. Right. Okay. And someone is trying to join. Excuse me. Yeah, Shiv Prasad. So I think I may wait a minute or so that right. Um, or else I'll continue, and if someone is joining, I'll have to come back and accept. So not a problem. Yeah. So in today's session, right, we will be discussing on the time domain description of SSB SC system. So what was SSB SC? SSB SC was single sideband with suppressed carrier, right? So we have initially studied about standard AM, right? Standard AM had carrier within it and two sidebands, so power wastage was there. Then we studied about DSBSC. DSBSC was actually what the carrier was suppressed, so it was nothing but M of t into C of t, or M of t cos 2 pi FCT. M of t cos 2 pi FCT, where cos 2 pi FCT is the, say AC also I should include M of t into AC cos 2 pi FCT. This was DSBSC, right? So then it had actually what both upper and lower sideband. Upper sideband was there, and also lower sideband was there. Right now, we know as it is like as upper and lower sideband are symmetric about the carrier frequency, any one of these sidebands would be more than sufficient. So to save the bandwidth further, we can suppress either lower sideband or upper sideband, or we need to allow only one. So SSB, it does that, and I told SSB can be obtained in a straightforward manner by actually what filtering this DSBSC. So today we are going to see how it can be obtained. If it can be obtained, what is the time domain expression? So we know what is the time domain expression of standard AM. It is AC into 1 plus KA M of t cos 2 pi FCT. Right, this is the time domain expression of standard AM. So DSBSC, it will be M of t times AC cos 2 pi FCT. So like that, what is the time domain expression of single sideband suppressed carrier modulation? So in today's discussion, right, what I'll assume is we are going to get a signal with only lower sideband retained. So I'll call this time domain expression as SLSB of t, which means it is an SSB signal with only lower sideband retained. So only this shaded part, it will be retained. The other part we have to remove. So we'll consider that. So I think we'll start with the discussion. Right. So we'll start with the discussion. I'll just clear this part. Okay. Right. So what happens is what actually is how SSB is generated. So we maybe DSBSC, right? So DSBSC, if this is DSBSC, so I'll call it a DSBSC time domain signal. I call as DSBSC of t, right? If we are passing it to a filter, we don't know what is that filter. I am assuming the filter has an impulse response HL of t, right? Then we will get SLSB of t, right? So this is some filter with impulse response HL of t. So it is a linear time invariant filter with impulse response HL of t, right? So that is actually what SLSB of t. So today what we are going to do is we are going to find an expression, right? We are going to what actually is SLSB of t, time domain expression for LSB of t, right? So before that, what is this SDSB of t? What was the time domain expression for DSBSC? So how DSBSC signals were obtained? So we had a product modulator, a simple product modulator, wherein to one input if I give M of t, and to the other input if I give AC cos 2 pi FCT, if I give AC cos 2 pi FCT, I will get SDSB of t. So SDSB of t is actually what DSB signal, right? And if you pass it through some filter, we don't know what is that filter and we don't know what is that. So these two things are what we have to find out in today's class, right? So now maybe if it is a linear time invariant system, I can write this SLSB of T, right? It is output of an LTI system with input equal to SDSB, right? So I can write it as SDSB of T. What will be that? It is into HL of T or convolved with HL of T. What is that? Can anyone unmute and tell? If you give SDSB of T as input to a filter with impulse response HL of T, what will be the output? It is a linear time invariant system, right? What will be that? Is it into or convolved with? Right. So maybe you can type.
Convolved.
It is convolution. Yes. So who told that? Pies. Right. Huh? Right. So it's
Sherwin Brian.
Sherwin. Okay, Sherwin. Okay. I'm in some different screen. I'm not able to actually see. I won't be able to see even if you are typing it in chat window. Right. So yeah. So it will be actually what SDSB of T convolved with HL of T. Right. So now we know what is this SDSB of T. What is this SDSB of T? SDSB of T. Maybe I'll write here SDSB of T. Right. It is nothing but what? AC times M of T into cos 2 pi FCT. Right. But we don't know what is this HL of T. We don't know what is this HL of T, and it is not right. So I know it's something. This filter should be something. It should actually what? Suppress the upper side band. Right. It should suppress the upper side. So if I discuss it in time domain, you won't get much clarity. Right. Maybe I should actually what? Transform this entire thing into frequency domain. If I transform this entire thing into frequency domain, right, there is an advantage. This convolution will become actually what? Multiplication. And one more thing, this visualizing this DSB spectrum, all those things are easy, right? So maybe we'll try and convert it into frequency. I'm going to take Fourier transform of this. So what I'll get S LSB of F. So please keep in mind. So if this should be actually what? When I'm writing time domain expression, I'll be using small s and subscript LSB and T. And this in frequency domain expression, normally we'll write actually what? Capital S, right? So capital S LSB of F is equal to capital S DSB of F into HL of F, where this H subscript L of capital H subscript L of F is nothing but what? The Fourier transform of H L of T, or else I can call it actually what? Frequency response. So now what is this SDSB of F? What is SDSB of F? It is nothing but Fourier transform of this, right? So SDSB of F. So if you have any doubt how it is obtained, so please watch the previous video. The last part of previous video I have explained, right, what is SDSB of F. So we do have an advantage in online mode of teaching. So whatever is done in one particular class, we are uploading the recorded session online, so you can always go back and refer, right? There is no like problem of forgetting to take down notes or nothing like that. So you can always go back and refer. And so because of that, at times some things I will be actually skipping, hopping you people to will be going back and referring the previous video, right? Or if you have any doubt, you can actually stop and ask. I'll be more than happy to do it here, right? So this AC M of T cos 2 pi FCT. So M of T, if spectrum of M of T is M of F. So Fourier transform of M of T, if it is equal to capital M of F, and if it is a baseband spectrum like this, which spans from W to minus W, right? So this is our assumption, right? Now this spectrum will be Fourier transform of this will be, so I'm taking Fourier transform on both sides. So it will be AC by 2 M of F minus FC plus M of F plus FC. So how we got this, right? I've explained it in previous video. I'm not doing it again. So but now what we want is we are getting this AC by 2 M of F minus FC plus M of F plus FC, right? So we know this SDSB of F, right? So maybe now we'll just try and plot that so that we'll get more idea how what this filter should be. So our main aim is to find out this time domain expression for SLSB of T or LSB modulated signal, right? So we are not going to try and find it out in time domain itself, but what we'll do is we'll first find out this We'll find out this first, then we'll take actually what inverse Fourier transform of this, and we'll obtain the time domain expression. That is what is our aim, right? So for that, the inputs, we know what is SDSB of f. So from the spectrum of SDSB of f, if I can successfully remove the upper side band, so whatever is remaining, that will be S LSB of f, right? So I'll just try and plot the spectrum. So if you can, right, you want, you can help me out, right? So the M of f minus fc, M of f I've shown, right? M of f I've shown, this is M of f, right? So M of f minus fc will be what? This M of f shifted right by an amount fc. So now I go to know, even after actually what we discussing these aspects in first session, some students are having some more doubt. How do I know this M of f minus fc is shifting right? How do I know this M of f plus fc is shifting left, right? So it's simple. Say whatever it is, right? Whatever function it is, whatever there inside this bracket, it is, maybe I can call it argument, right? Say if the function can be actually what, sine of something, or cos of something, or e power j something, right? Or else actually what, del of something, right? Or x of something, right? Whatever it is, right? So this is actually its argument, and this whatever is there inside this argument, right, it corresponds to the value of this actually what, independent variable, whatever it is. It can be time. If it is a time domain expression, whatever is there inside can be a function of time, right? If it is a frequency domain expression, whatever is there inside can be a function of frequency, right? So now this is I know you are able to appreciate this is shifting, but if it is shifting right or left, if you have to know that, right? So you can see where this point corresponding to what, 0 is shifting, right? In this M of f, we do have a point corresponding to 0, where this point corresponding to 0. So if it is M of f, right, whatever is, if whatever is there inside this bracket, if it is equal to 0, right, that should be same. So if I say f minus fc is equal to 0, right, f minus fc is equal to 0, which implies f is equal to fc, right? So this M of f minus fc, this f minus fc has to be, if it has to be 0, that will happen only when f is equal to fc, right? So whatever was there in 0, now whatever happened at f frequency instant 0, now it will happen only at frequency instant fc. That is the meaning of that. So we can shift it, right? So we have to shift it, right? So this is actually what, fc, and this part will be M of f minus fc. So this part will be ac by 2 times M of f minus fc, and ac by 2 M of f plus fc will be this part, ac by 2 M of f. So this is minus fc. So this is, I'll draw it. This is actually what, S DSB of f, spectrum of DSB signal, right? Now what we want to do is, I need to retain only lower side band. Retaining only lower side band means I'll shade the lower side band, right? So this part I have to retain, and also this part I have to retain, and the unshaded regions I have to actually what, clip off, or I have to remove, right? So removing in frequency domain, right? Removing in frequency domain means actually what, filtering out using some filter, right? So what should be the frequency response of a filter, which will allow only this much part, minus fc to plus fc, and which will eliminate everything, right? So now I am getting an idea. So this HL of f, right, HL of f, right, it should be equal to 1 from minus fc to fc, and it should be 0 elsewhere, right? So what my requirement is, I need to retain this and this part and remove everything, right? So either I can have actually what, a band pass filter which allows from fc minus w to fc plus w, right? So but instead of that, right, as we don't have any content from this to this, right, that is from fc minus fc plus w to, right, from here to here we don't have any content. So what I can do is, I can use a filter like this. So if I draw that, I think you will get a better idea, right? So my filter should be right? My filter should be something like this. So it is FC and it is minus FC. So this is actually what, this should be my HL of F, right? This should be my HL of F. So the expression I'm writing once again. So what is our S LSB of F? S LSB of F is equal to S DSB of F into H L of F, right? SLSB of F is equal to SDSB of F into HL of F, right? So this is SDSB of F and this is HL of F. Now I can straight away multiply this. So then I should get SLSB of F. So let us see whether we are getting that, right? So now I'll just try to draw it to the same scale, right? So this is say FC and this is minus FC. This is, I'll mark this is actually what, FC minus W, and this is minus FC plus W, right? So what we'll get now is we'll get something like this, right? This is minus FC and this is minus FC plus W, and here again we'll get, right, this is FC and this is FC minus W. So this is what we will get now, right? This is what we will get now, right? So this is nothing but what, our S, S LSB of F, right? So this is our SLSB of F. So it has got only actually what, lower side band is there, right? So this is upper side band, right? These two are upper side bands, and this is actually what, lower side band and lower side band, right? So now only lower side band is there. This is actually what, S LSB of F. So I forgot to mention, in all these cases the independent variable, it is actually what, frequency domain. So this is actually, this is how we can visualize the generation of SSB in frequency domain, right? So this is the basis, right? So this is how we are getting SLSB. Now how can I write the frequency domain expression for SLSB of F, right? What will be this? So I can draw this, right, but I can write it in a piecewise way. But if you write like this, it won't suffice, right? So maybe I should write it using some mathematical functions, right? I should write it using some mathematical functions. So what is that I have to obtain is this frequency response, right? So this, okay, I hope you can see this. This frequency response is what I have to obtain, right? So this frequency response. So what I'll do is I can write using signum function this frequency response. HL of F will be equal to half of signum of F plus FC minus signum of F minus FC, right? So we will just see how, like, you don't have to what, bluntly accept it, right? We'll just verify and then accept. So either I can write it as actually what, HL of F is equal to 1 from minus FC to FC and 0 elsewhere. But if you write like that, that is actually what, it's common man's language. It is not the language of math actually, right? So if you want to write it in terms of math, right, I should write it in terms of some standard function. So you know, I hope you know what a signum function. Can anyone tell me what a signum function? In yesterday's video, those who have seen, they'll be knowing what is a signum function. Can anyone unmute and tell? What is signum function? If I may ask Anup V. Shetty, what is a signum function? No, so those who know, please can answer, right? Or else okay, as I told, right, maybe I should not ask questions, right? I should be giving answers, right? So signum function, it is this, it is -1 for if signum of F is what I want, right? So right, it will be something like this. This is F is equal to 0, right? For F greater than 0, this will be equal to +1. F less than 0, it will be equal to -1. So I can write it here. I'll write it here. Maybe somewhere here I'll write signum of F is equal to, right, it is equal to +1 for F greater than 0, right? 0 for F equal to 0 and -1 for F less than 0, right? This is signum function, this function, right? So now what I need to obtain a characteristics like this. So from minus FC to plus FC, it should be equal to 1, and it should be 0 elsewhere. Right. So now I've told it we can obtain it like this. Right. So maybe we can just verify. So now what will be signum of F plus FC? I'll draw it here. Right. What will be signum of F plus FC? This is signum of F. Signum of F plus FC means I told you how to think. Right. F plus FC equal to 0. When this F plus FC will be equal to 0, it happens when F is equal to minus FC. So what happens is whatever is the value of signum of F at F is equal to 0, right? That has to be happening at F is equal to minus FC. So it should be left shifting, right? So this entire function will shift left. So this is equal to minus FC, right? And 1 and minus 1. So this is actually what signum of F plus FC, right? So this is signum of F plus FC, right? So now what is signum of F minus FC? It will be actually what shifted right. F minus FC will be what the function, entire function shifted right. So it will be shifted to plus FC. Entire function will be shifted to plus FC. This is FC. This is 0, right? So this is minus 1, and this is actually what plus 1, right? And okay, so if you add, so now what if I have to get HL of F? What I told I should subtract. So I'll write it here. So this is signum of F minus FC, right? This is signum of F minus FC. So what will happen if I subtract signum of F minus FC from signum of F plus FC, right? So maybe you can divide it into what different pieces, right? Say this is FC, right? If you see for frequencies greater than FC, right? So I'll maybe I can write it here. I'll write with some other ring, right? For this, right? So maybe I can write it here. So half is equal to, right, half into, right? For frequency greater than FC, it's equal to what? Signum of F plus FC is 1. Signum of F minus FC is also equal to 1. So it will be 1 minus 1 for frequency greater than FC, right? And what will be that for frequency between plus FC and minus FC? That is minus FC less than F less than FC. What will be that? How you will subtract? So it is half into, right? What is the value of signum of F plus FC between minus FC and plus FC? That is equal to 1, right? And what is the value of F minus FC between plus FC and minus FC? That is equal to minus 1. So this will be equal to half of 1 minus of minus 1, right? So that, right, so that is actually what. Now maybe no, I don't want to include okay, half here. Why? Because I'm just subtracting this part. I'm considering this half, let it be outside, right? This half, let it be outside, right? Why? Because I'm just subtracting signum of F minus FC from signum of F plus FC, right? Maybe I should write it somewhere else, otherwise you may get confused, right? So please wait. Right. So maybe it's better if I write it somewhere else, right? Otherwise you're going to get confused, right? So this I'll write here only, right? Somewhere here I'll write, right? Towards the right I will write. So this will be signum of what is that I want to obtain now, right? I want to find what is signum of F plus FC minus signum of F minus FC, right? So I am going to divide. So first region is actually what, when F is greater than FC. When F is greater than FC, you can see it is actually what, 1 minus 1, right? So it is equal to 1 minus 1 for F greater than FC, right? And between, right, minus FC less than F less than FC, that will be equal to what? 1 minus of minus 1, 1 minus of minus 1. And for frequencies less than minus FC, right? For frequencies less than minus FC, right? What is that? It is minus 1 minus of minus 1, right? It is minus 1 minus of minus 1. right? Which means this is 0 and this is also 0, this is equal to 2, right? Are you getting this? It's straightforward subtraction of two signals, right? So if I draw it here, the resultant should look like this, right? The resultant should be equal to 2. It should be equal to 2 from FC to minus FC and 0 elsewhere. This is nothing but what? Signum of F plus FC minus signum of F minus FC. So this is how the resultant will look like, right? This is how the resultant will look like, right? Now, what does that we want? We want something, it should be 1 from minus FC to plus FC, but what we have is 2 from minus FC to plus FC. So to make it 1, what I can do? I can scale it by a constant which is equal to half, right? So that is what is done here, right? I have scaled it by a constant equal to half. So signum of F plus FC minus signum of F minus FC. So I've drawn it in detail here, right? This is signum of F. This is signum of F plus FC. It is actually what? Signum of F shifted left, or signum of F shifted left by an amount FC, right? Signum of F minus FC will be signum of F shifted right by an amount FC. And and signum of F plus FC minus signum of F minus FC will be 2 from minus FC to plus FC. But for us to get the desired HL of F, I should scale this by half, right? So this is our desired HL of F, right? So this is our desired HL of F that you have to, right? You have to appreciate it, right? Why? Because we have verified it. It is true, right? Now at this point, if you have any doubt, anyone is having any doubt, I would like to take any doubts. If you have, I would like to address, right? Please say yes or no, or if any other option, right? Any doubt? Am I audible first of all?
Yes, sir.
Right. So like if anyone is having, or else I'll ask some like people, if I may ask, Samartha, do you have any doubt till here?
No, sir.
No, like is it clear? Right. Now
Yes,
what
sir.
we have done is till how we found this HL of F, the frequency domain expression HL of F, that is clear, right? Okay.
Yes, sir.
Now if I may ask, say Shiva Prasad,
Yes, sir.
do you have any doubt?
No, sir.
No, in the sense a complete no, or some doubt is there somewhere?
Like if you go back, like
Yeah. Please ask doubts. Right. Yeah. Where should I go?
filter,
Huh?
filter, sir.
Filter. Okay. 1 second. Yeah. This is a filter. Yeah.
The difference between like a band pass filter and this filter.
Difference between a band pass filter. So this is actually a low pass filter which will allow from 0 to FC, right? A band pass filter will have a lower cutoff which is other than a band pass filter. If I draw a band pass filter, right, it will be something like this, right? It will have a lower cutoff, and it will have a higher cutoff, right? But here for convenience, this is once again I'll tell, this is actually what mathematical modeling what we are learning. This is as per ideal case, theoretical, right? So in practice, we have to use actually what a band pass filter. To obtain this, we'll be using a band pass filter which will remove this part, upper side band part. But as we don't have anything in between minus FC plus W and FC minus W, right? So using a band pass filter, right, which will eliminate this part, right, or which will allow only this part, right, whatever, it is same as actually what using a low pass filter which will allow these much frequencies, right? So right, so that's what, why I am able to do that is, right, just keep in mind from FC minus W to minus FC plus W, we don't have anything, right? It's equal to 0, right? So it doesn't matter whatever be the value of this here, but right, for us to mathematically model, this is more convenient. I can model it using signum function, right? So that's why we have chosen it. Right. Is that clear, Shiv Prasad?
Yes, sir.
Okay, yeah. Fine. And any other doubt?
No, sir.
Right. Okay. If I may ask Swaroop. Swaroop. Like if I call, you should either unmute and say hi, or else you should type something in chat window. Otherwise, right, it means you are not physically present at the other end. You are doing something else. Swaroop sir. Okay, Tejashri.
Yes, sir.
Yeah. Do you have any doubt, or are you clear with this, what we have discussed so far?
I understood, sir.
Understood. Okay, fine. Right now, I'll ask one more person. Swaroop is typing, I can't use my mic. Right. So at least you can type in. If you have any doubt, you can type in. So I'll ask Vinuta. Vinuta. Yeah, is it clear? Do you have any doubt? If yes, you can, right, you can either type it in chat window or you can unmute and tell. Otherwise, okay, fine. So we'll continue. So now what we have done so far is, right, I'll just consolidate, right. So we know the SLSB of F is equal to S DSB of F times HL of F, right. So this SDSB of F we knew already. So that is equal to what? That is equal to AC by 2 times M of F minus FC plus M of F plus FC, right. So but we didn't know what is HL of F. Just now what we did is we found what is HL of F. Now can anyone tell me what is HL of F? Unmute and tell. What is HL of F? Yes. Half times signum of, yes, someone can help me out, right? Just now we saw that signum of, yeah, Sukti, what is that? What is HL of F? Just now we derived it, right? What is HL of F? Right, no response, right? So half time signum of F plus FC minus signum of F minus FC. So this is what we got now. Now what we can do is we can actually what straight away go on expanding it, right? And we can obtain a compact expression. And if you take inverse Fourier transform of that, that will result in our time domain expression. So maybe we can go on expanding it, right? So it is AC by 2, right? Sorry. Right, so first AC by 2 M of F minus FC into half signum of F plus FC. So it will be, I can write AC by 4 M of F minus FC into signum of F plus FC, right? AC by 4 M of F minus FC times signum of F plus FC. So please keep in mind this was asked in 2018 university question paper, right? But of course it was for 2015 scheme. But in VTU quite a few times we have seen, even though the scheme has changed, right? The textbook reference which they have given us entirely different, right? We have seen people asking questions from previous scheme as well. So you can't go and complain at that time, right? So, right. So AC by 4 M of F minus FC signum of F plus FC plus or minus next AC by 2 M of F minus FC times minus half signum of F minus FC. So it will be minus AC by 4 M of F minus FC times signum of F minus FC, right? Then what will be the next term? So next term will be plus AC by 4 m of f plus fc times signum of f plus fc, right, and minus AC by 4 m of f minus fc times signum of, sorry, did I okay, f minus, yeah, is AC by 4 m of f minus fc, so it should be f plus fc, right? It should be f plus fc times signum of f minus fc. So we have this much now, right? So now we have terms m of f minus fc into signum of f minus fc and m of f plus fc into signum of f plus. Those two terms will, right, retain it as such, right? Why? Because those who have seen yesterday's video, right, we have defined Hilbert transform using like the frequency domain, or if you frequency domain representation of a Hilbert transformer, if you are assuming it as a filter, it is actually what, minus j signum of f. Maybe somewhere you can use that. So just keep in mind, right? So whatever terms we have here, so m of f minus fc into, if both arguments are f minus fc or f plus fc, we don't have to alter it, but we have to just inspect the other terms. One is actually what, AC by 4 m of f minus fc into signum of f plus fc, and other one is m of f plus fc into signum of f minus fc. So when it changes, you have, maybe you can actually what, try and change that, right? So how to do that? So m of f minus fc into signum of f plus fc, we'll just try and see what is it. So m of f minus fc, I'll draw it here. M of f minus fc will be m of f shifted right by an amount fc, right? And signum of f plus fc will be, signum of f plus fc will be signum of f shifted right by an amount fc, right? So this is m of f minus fc, and this will be actually what, signum of f plus fc. So signum, value of signum of f plus fc, right, for frequency greater than minus fc, it is equal to 1. So if you multiply these two, right, if you multiply these two, what you will get? You will get the same m of f minus fc, right? So this will be m of f minus fc itself. How? I'll tell, right? You're multiplying m of f minus fc, right? M of f minus fc is defined from fc minus w to fc plus w, right? Over this period, right, it is equal to what, 1. So if you multiply that with 1, it will be same. And otherwise, for all other frequencies, m of f minus fc is equal to 0. So whatever be the value of signum of f plus fc in frequencies other than actually what m of f minus fc is defined, we don't bother, right? So this term will reduce to actually what, this first term, right? I'll write here now. This first term, it will reduce to AC by 4 into this m of f minus fc into signum of f plus fc will reduce to what, m of f minus fc, right? It will be m of f minus fc, right? We have seen how, right? So now I'll ask a question. Did anyone understand this? Did anyone understand this, what I just now told? At least I'm not asking everyone, right? Anyone. Tejashree has typed something. I think she has typed it some time before. No. Right. So are you able to appreciate, or are you able to what, accept this m of f minus fc into signum of f plus fc is equal to m of f minus fc? Yes or no? Please do respond. Yes. Right. At least one response if I'm getting, right. Maybe I can, I don't expect what everyone in this class will be able to what, understand or appreciate everything at the options. Yes, Savan has typed option 3. Yes, thank you, Savan. Yeah. So anyway, I'll make this video available. You can actually watch it either at 3x or maybe 0.5x or whatever you want. You can watch any number of times as you want, right? So, but please make it a habit. If you have any doubt, please feel free to actually stop and ask, right? So make it a habit, ask doubts, right? Okay, so this first term will be AC times m of f minus fc. So now we'll consider what, similarly I can show that this m of f plus fc into signum of f minus fc, right? M of f plus fc into signum of f minus fc, maybe, right? I'm not telling similarly we can show, we'll just draw it and see, right? So what is m of f plus fc? M of f plus fc will be m of f shifted left by an amount fc. And what will be signum of f minus fc? Signum of f minus fc will be signum of f shifted right by an amount fc. So m of f, this is m of f plus fc, and this is signum of f minus fc. So you can see here over the frequency ranges where m of f plus fc is defined, signum of f minus fc is equal to minus 1. So this product will become actually what, AC by 4 into minus of actually what, m of f plus fc, right? This product will become actually what, minus of m of f plus fc, right? I hope it is clear, right? I hope it is clear. So now, yeah, so AC by 4 m of f. So I'll write that term. So last term I am writing as second, right? So plus AC by 4 into, or plus and into minus, actually it will become minus, right? So instead of writing plus into minus, I'll write actually what, I'll write it as, sorry, right, I'll write it as minus only, minus m of f plus fc, right? So this is, maybe I'll make it as one group. Now I have other two terms. What are the other two terms? They are, right, maybe I'll take it minus AC by 4, right, m of f minus fc into signum of f minus fc plus AC by 4 into m of f plus fc times signum of f plus fc. So we have these terms now, right? So now we have these terms, right? So the first term, so maybe I'll just actually rearrange it slightly and I'll write it neatly, right? So what actually is this? What is that we are writing? If you go above and see, this is equal to what, SLSB of f. Now I'll write the frequency domain expression of SLSB of f, right? So maybe, yeah. So SLSB of f, SLSB, sorry, yeah. LSB of f, SLSB of f is equal to, right? So I'm just going to rearrange it. So first term is, there is an AC by 4, m of f plus fc and m of f minus fc, right? Or did I make any mistake anywhere? So this is the last term. Is it plus or minus? AC by 4 m of f minus fc. This last term is minus, right? This is minus, right? So I made a mistake here. If you just remember, if you just see where I replaced, right? So this is actually what, minus of AC by 4 into minus of m of f minus fc. So this should be plus, right? Here, if you can see my pointer, this one would have been plus, right? So this one would have been plus. Why? Because there is a minus already. Then m of f plus fc into signum of f minus fc will be minus of m of f plus fc, right? So that minus and minus will be plus. So please note it. So that should be a plus, right? So it has to be a plus, right? So it is, I'll write AC by 4 times, AC by 4 times m of f plus fc plus m of f minus fc, right? AC by 4 times m of f plus fc plus m of f minus fc, right? Then what we have is AC by 4 into, right? So maybe I'll write the plus term first, right? I'll write the plus term first, right? So I'll write plus, right, AC by 4, I can take common out. So AC by 4 into, now I can write, right, m of f plus fc times signum of f plus fc, m of f plus fc times signum of f plus fc minus m of f minus fc minus m of f minus fc times signum of f minus fc, right? So we can write it like this now, right? So if you see here, right, so maybe those who have seen yesterday's video, they will be able to appreciate, right? So maybe if I have like, so I'll just have a small like recap on Hilbert transform, right? So those who have not seen yesterday's video, I request you to what, see that if you find some lack of clarity is there, you should, it's because of actually you don't know what is Hilbert transform, right? So if I have a time domain signal m of t, right, its Hilbert transform will be, if its Hilbert transform will be represented as m cap of t, and we have even seen in yesterday's video what is the definition of Hilbert transform, what it does. A Hilbert transform, what it does is it phase shifts all the positive frequency components in the signal by minus 90 degree and all negative frequencies by plus 90 degree. So the resultant signal, or if you apply Hilbert transform to a time domain signal, the resultant signal will be in time domain itself. So that time domain expression I can write as actually what, m cap of t is equal to what, either m of t convolved, sorry, m of t convolved with 1 by pi t, right? Or I can write in frequency domain. So those who have not watched yesterday's video, please watch that. In that I have in detail explained, right? Or else in frequency domain, right? In frequency domain, right? If m cap of f was Hilbert Fourier transform of m cap of t, so I can write m cap of f is equal to, right, m of f, right, into the Fourier transform of 1 by pi t, Fourier transform of 1 by pi t, it is equal to minus j signum of f, right? So right, I didn't mention how to prove it. It's right, maybe you can prove it in different ways, but anyhow you will study those things in detail in 6th semester, right? It's not a part of our syllabus. Even then, right, if you know this, if you are able to what, accept it, 1 by pi t, its Fourier transform is minus j signum of f, right? So this, right, m of t convolved with 1 by pi t, right? So in frequency domain, convolution will become actually what, multiplication. So it will be m of f multiplied with minus j signum of f, right, minus j signum of f. So it is actually what, minus j signum of f into signum of f into m of f. This is actually what, m cap of f. M cap of f was defined as minus j signum of f into m of f, right? Or else I can write signum of f into m of f will be what, m cap of f divided by minus j, right? Or minus 1 by j times m of f will be what, signum of f into m of f, right? So instead of this f, right, if you replace this f with actually what, f plus fc, in both cases, both f, if you replace with f plus fc, what will happen? It will become m cap of actually what, here also you can replace f with f plus fc. Instead of f, you are replacing it with an elephant, right? J signum of elephant, right? So I'm simply telling, right, instead of f, if you are replacing it with f minus fc, if both f's are replaced with f minus fc, then it will become actually what, m cap of f minus fc, right? So now you see here, that's why, right, as I had the definition of Hilbert transform in my mind, I told I need not actually alter the signals with actually what, the f plus fc and f, same things in the bracket, same things as argument of m and signum, right? So now I can write this m of f plus fc into signum of f plus fc will be what, minus 1 by j signum of minus 1 by j m cap of f, right? So this thing, whatever is here, right, it will be minus 1 by j minus 1 by j m cap of f plus fc, and this will become actually what, this thing will become minus 1 by j m cap of f minus fc. So those who have not watched yesterday's video, again I repeat, you must watch that, then you will get a better clarity. So now we have actually what, AC by 4, AC by 4 m of f plus. So I'll once again I'll rewrite it, right? So I'll take maybe yeah, so I'll rewrite SS. So this was actually some prerequisite which was required. I just mentioned. So I just discussed, right? So now SLSB of f, SLSB of f is equal to what? It is AC by 4 m of f plus fc plus m of f minus fc, right? So it is AC by 4, right? So instead of that, right? Okay, AC by 4 m of f plus fc into m of f plus fc plus m of f minus fc, right? Then what I have here is the first term, AC by 4, the first term will be actually what? I can replace this with minus 1 by j m of f m cap of f plus fc. That is nothing but what? Minus 1 by j times Hilbert transform. It's plus or minus, it's plus, right? So it's plus, right? Or else I'll write it down, plus, right? So it's plus AC by 4, right, times minus 1 by j m cap of f plus fc, right, minus 1 by j m cap of f plus fc, right? And again, what we have, what is the next term? It is minus of minus 1 by j m cap of f minus fc, right? It is minus of minus 1 by j, right? It is minus of minus 1 by j m cap of f minus fc, right? So we have this much now, right? So now this is equal to, right, again AC by 4 m of f plus fc plus m of f minus fc, right? Plus, so this say 1 by j I can take outside, say, or else minus 1 by j I can take outside, right? This minus 1 by j I can take outside, right? So if I take this minus 1 by j outside, it will become actually what? Minus AC by 4j, right? It will become m of f plus fc minus m of f minus fc. It will become m of f plus fc minus m of f minus fc. So this is what we are getting. Now what I need is, if I need to get the time domain expression, right? So if I need to get, so this is what we have now, right? So if I need S LSB of t, SLSB of t, I should take inverse Fourier transform of S LSB of f, right? But you remember what is half of m of f plus fc plus m of f minus fc, right? What was the Fourier transform of m of t cos 2 pi fct? You remember that? Anyone remember what is the Fourier transform of? My question is, what is the Fourier transform of, right? Fourier transform of, I'll use some other ring, sorry, right? M of t cos 2 pi fct. What is the Fourier transform of this? This is nothing but what? M of f plus fc plus m of f minus fc, of course, right? There will be a half, right? M of f plus fc plus m of f minus fc, right? So similarly, what will be the Fourier transform of m of t sine 2 pi fct? What will be Fourier transform of m of t sine 2 pi fct? What will be Fourier transform of that? If Fourier transform of m of t is m of f, right? What will be Fourier transform of m of t, right? M of t sine 2 pi fct? This is a question, right? So I'll just help you out. So normally someone asked me actually why only cos 2 pi fct you are considering, why not sine 2 pi fct, right? So before I can solve this, maybe I'll take some 5 more minutes, right? Excuse me, right? We are almost done, right? I should find out this. That's it, right? I should find out only this. That's it, right? So what is m of t of Fourier transform m of t sine 2 pi fct, right? What is that? Right, maybe okay. We should not discuss it. Other way also I can actually what find out this, right? So there is another way also for me to what find out this. For but you should appreciate, right? This m of f plus fc plus m of f minus fc is nothing but what, to like, or half of m of f plus fc plus m of f minus fc is nothing but the Fourier transform of m of t cos 2 pi fct, right? So this entire thing, it's inverse Fourier transform, right? This entire thing, it's inverse Fourier transform. I'll write here. It will be, right? So I'll write here now S LSB of t will be actually what, inverse Fourier transform of this entire thing, right? Inverse Fourier transform of this first term will be, right? First term will be, I'll write here. I need you to just slightly think it through, right? AC by 2 into m of t cos 2 pi fct, right? So that is equal to AC by 2 m of t cos 2 pi fct. So inverse Fourier transform of first term will be AC by 2 times m of t cos 2 pi fct, right? Now we find out the Fourier transform of other terms. Maybe I don't want I don't want you to know what is m of t into sine 2 pi fct. Without knowing that only, right? So we know one more result, frequency shifting property, right? Even frequency shifting property, somewhere asking the proof for frequency shifting property. How can you tell if you multiply m of t with e power j 2 pi fct, the spectrum is getting shifted by an amount fc? How can you tell that? Some people ask me, right? For that, again, proof I have included in last video, right? So we know, right, m of t into e power j 2 pi fct, that is the frequency shifting property. Its spectrum is equal to what? M of f minus fc, or else I can write in general m of t plus or minus e power j 2 pi fct will be m of f plus minus or plus fc, right? So I have m of f plus fc here, right? So I'll write here minus ac by 4j, it's a constant, right? What will be inverse Fourier transform of m of f plus fc? Inverse Fourier transform of m of f plus fc, it will be equal to, it should be m cap, right? It should have been m cap. I missed that m cap here, right? Sorry, it should have been m cap, right? It should have been m cap, right? While taking it down from here to here, I missed that m cap. Please excuse, right? So it will be actually what, m cap of t into e power minus j 2 pi fct, right? And minus this will be actually what, m cap of t into e power j 2 pi fct, right? So we have this now, right? So this much we have now, right? This much we have, right? So now again I'll write AC by 2 m of t cos 2 pi fct, AC by 2 m of t cos 2 pi fct, right? So I have actually what, this minus if I'm taking inside, right? This minus if I'm taking inside, right? And m cap of t also, I think I can take it like a common, right? So this minus I'm taking inside, I'm slightly rearranging, so it will be plus, right? AC by 2 m cap of t, AC by 2 m cap of t, there is a reason why I'm doing this, right? Into, right, this e power j 2 pi fct minus of e power minus j 2 pi fct whole divided by 2j, right? What actually is this? Whatever I have written in this, inside this bracket, what is this? Can anyone tell me? what is this inside this bracket? Please, I need an answer. Right. So this is very basic thing which we have discussed in the first. Yeah, some have Sherwin has told it is sine 2 pi FCT. Exactly, right. It is sine 2 pi FCT. So those who have doubt, right? Those who have doubt, I can tell, right? We told e power j theta will be actually what? Cos theta plus j sine theta, right? And cos theta, the real part of this will be actually what? E power j theta plus e power minus j theta divided by 2, and sine theta, the imaginary part of this will be actually what? E power j theta minus e power minus j theta divided by 2j, right? So this you can see e power j theta minus e power minus j theta divided by 2j, right? So this is just a result, right, which we have already discussed in the very first actually what session, right? Again, those who have forgotten that, I'm just mentioning it once again, right? So what we have now was, right, this is LSB of, sorry, SLSB of t is equal to, SLSB of t is equal to AC by 2, right? Sir, you have a session now, sir? Okay, yeah, I'll find out. Yeah, AC by 2 times m of t cos 2 pi FCT plus AC by 2 m cap of t sine 2 pi FCT. So this is the time domain expression of LSB signal, right? So I just initially I just mentioned we can actually, if we need to analyze the time domain expression of single sideband system, we need to have a knowledge on Hilbert transform, right? So you can see this is actually what m of t cos 2 pi FCT plus AC by 2 m cap of t is nothing but what? Hilbert transform of m of t times sine 2 pi FCT. This is for actually what? LSB, lower sideband, right? So SSB with only lower sideband retained. If I need SSB with only upper sideband retained, right? In the same manner, right, we can prove that the time domain expression will be equal to AC by 2 m of t cos 2 pi FCT minus AC by 2 m cap of t sine 2 pi FCT, right? So in sixth semester, right, again in detail you will study about this. You will call it actually what? Canonical representation or something, right? So but now, right, for you to remember, why? Because this is required. This is required for you right now. It was asked many times in exam, right? And also for to solve numerical example, you should know this, right? So this is the what is meant by LSB of t. When I write the subscript as LSB, right, it means it is an SSB system with only lower sideband retained, upper sideband is rejected, right? When I write SUSB, it means only upper sideband is retained, lower sideband is rejected. So if you want to retain only upper sideband, right? If you want to retain only upper sideband, maybe we can see what should be the filter response, right? So if you want to retain only upper sideband, this is what you have to retain. Only this part is what you have to retain. For that, you should have a filter which is like this, a sort of actually what? It will, right, block or say a high pass filter, right? A high pass filter with this characteristics would be, right? So this, if you can write in terms of actually what? Signum function. This if we can write in terms of signum function, then remaining everything will be same, right? So this is what is actually what the time domain expression for SSB system, right? And coherent modulation, product modulator and coherent demodulation, everything remains the Same, right? Maybe while solving problem, I'll discuss, right? Next one would be a problem, right, which we'll be solving. A part of it we'll solve, and the second part will be given as assignment. So while solving problem, I will discuss more in detail about actually what SSB detection, right, and what happens if there is some delta F or some frequency error between transmitter and receiver, right? All those aspects will be discussed along with the problem. But for you to appreciate and accept what will be discussed in that problem, these fundamentals are necessary. So this is how we obtain the time domain expression of SSB. Right. So what we have done is initially we obtained frequency domain expression, and then we have we have taken its Fourier transform, right? So that's it. So that's all about today's session, right? I hope today I tried my best not to ask questions. Right? I tried my best not to ask questions, right? And you tried your best not to answer any questions if at all I ask, right? Very good. Yeah. So any doubt so far you may please ask, right? Otherwise, I will wind up. So those who have not watched the previous video recorded session, you should watch that, right? And this, right? I'm not asking you to watch entire thing. Maybe wherever I have mentioned about Hilbert transform, right? So those who are not yet clear with Hilbert transform, what is Hilbert transform, you can watch that, right? I've mentioned in detail, right? So that's it for today's session. If no doubt, right? So before that, I maybe at least, right? What is that? It's option 1, 2, or option 3. Please also believe if you just go through this video once again, you will be able to understand. Option 3, maybe if and either, okay, if those who think you won't be able to study it at all, that is option 4, right? You'll skip this topic. So option 3 means, okay, now you don't have any doubt, you will be able to manage it. Option 4 means you have doubt, right? You don't want to clear it, right? You don't want actually what, maybe you will be skipping that. Maybe I'll take option 4 as that. Yeah, okay, maybe we'll end up the session today, right? Thank you. So tomorrow we have a live session. Maybe in that live session we'll solve the problem on this SSB, right? A numerical example we'll solve, and tomorrow only I'll assign that assignment, right? It's actually common for both A and B section, right? So this will be maybe say first graded assignment. Thank you. You can leave if you have any doubt. You can stay back. Otherwise, you can leave.